we could take 2x plus 6 is greater than 4, but knowing then that this is where they were less than one another, knowing that at -5 and -1 that's where they were equal to one another, should I be able to interpret the rest of the number line as where they're unequal to one another in the fashion of being greater than? Does that kind of make sense? Okay. It's the complement idea. If I know I've got basically 3 regions. I've got equality, I've got less than, and if I know where those 2 regions are, I automatically know the default 3rd region of greater than. Does that make sense to everybody? Okay. And you might see that in WebAssign. I know when we had Math Excel will do that. They give you 3 options or 3 parts of the question, and they say find out where they're equal. And the next question was find out where they're less than. Well, then the 3rd problem, you don't have to do anything because you know where they're equal, you know where they're less than. Everywhere else on my number line is where they're greater than. Does that make sense? Okay. So here we should be able to say from -infinity up to -5, and from -1 all the way to positive infinity is where the orange one is greater than 4, right? Okay. Let's go through the algebra and see how we can replicate that. Just generally speaking, when we have like an ax plus b is greater than c now, okay? Going back just to a linear, one-dimensional number line here, okay? If I start, zeros here, let's say c is there, let's say -c is there. If ax plus b is greater than c units from 0, that expression is greater than c units from 0. So I'd be looking at something that looks like that, right? Okay? Ax plus b is greater than c units from 0. And that would just be simply finding that set of solutions, would just be taking ax plus b greater than c and solving that inequality. Okay? But if I'm over here, isn't that distance there greater than c units away from 0 as well? Yeah. Okay? So we'd actually have to figure out how we can incorporate those. Okay? Well, graphically speaking, if I want to take that graph and translate it into an algebraic expression, these values are less than -c, aren't they? So we're going to write ax plus b is less than -c. Okay? And those are the 2 things that we come up with. We write the word or with them. But those are the 2 inequalities that we come up with to solve a greater than question for absolute value. Okay? One thing, I don't know if I mentioned this, whenever you're doing absolute value, if I have 4 is less than absolute value of 2x plus 6, I write it that way. I want to read it from the absolute value first. Does that make sense? So I read it, absolute value of 2x plus 6 is greater than 4, because then it gives me this rule. Alright? I don't want to read it as 4 is less than, because then people are going to get stuck and they're going to do this, which is incorrect. Does that make sense? Okay? You've got to read it from the absolute value first and then to the constant. Okay? So, looking at this one, we're going to come up with 2x plus 6 is greater than 4. Do a little bit of work there. And then we're at 2x plus 6. Okay, this rule is saying flip the inequality symbol. Goes the opposite direction. So now we're trying to find these solutions over here. And then you take the c value and make it negative. So, negative. Now you just solve those 2 inequalities. 2x is greater than -2. X is greater than -1. And then here, 2x is less than -10. X is less than -5. And that's what we got here, right? That's what we kind of anticipated having, is at that point right there is -1. Then to the left of that is where the orange line was above the blue one. Okay? And that is infinity up to -5. And then that value there is 1. That direction from -1 to positive infinity is another place where the blue one, the orange one is above the blue one. Okay? Now when we write our answers, we want our answers in interval notation, right? So x is greater than -1. How would I write that? If I'm thinking about a number line, I'm thinking about numbers that are greater than -1. What would be the first number you come across left to right? -1, right? Okay? If I'm thinking about something like this, right now we're saying we've got -1 right there. And we want numbers that are greater than that. Well, we want to identify in interval notation that red ray. Well, it starts at -1 and it's going to go to what? Infinity. Okay? Now this one here, x is less than -5. So if this is -5 over here, we want to identify in interval notation that ray. So what number do I start with? -infinity, right? That's the first number I come across, all the way to the left. And what would be the last number you come across on that ray? -5. Okay. So, still not done though. Because we want to make sure that we understand when we have the word or, and I erased it, but that word or means union, right? That means you got to stick your two solutions together. Alright? So we got to tell everybody that these could be answers, or these are answers. Okay? So any point that shows up on here is an answer, or any point that shows up over here is an answer as well. Okay? So we got to put those together. And now when we put these two things together, we want to make sure that they're in chronological order. They represent a number line. So what is the number that is furthest to the left in these two things here? -infinity. So that one comes first. Union then, -1 to infinity. And that should mimic then the number line that we have, that we're looking at. Is that doable? Okay. When you're working on this stuff, my suggestion, at least early on, every time that you come across one of these inequalities, okay, something that's safe to do is to first rewrite it so the inequality comes first. Okay, so if I had like 13 is greater than absolute value of 2x plus 5. Okay, I'm going to use my symmetric property of equations and inequalities, and I'm going to rewrite that as absolute value of 2x plus 5. Now, that absolute value bar, it's pointing, if that was an arrow, it's pointing to the 2x plus 5, right? So it's still got to point to the 2x plus 5. And then I had my 13. And now that helps me use the correct rule that I'm going to basically do this. 2x plus 5, less than 13, and I'll put in the -13 over here. Okay? I think that's the safest thing to do. People get themselves in trouble when they leave it this way. And professors, people that write standardized tests, college entrance exams, whatever, know that people are going to get themselves in trouble when they do this. So it's inevitable that you'll see something like this on tests. Does that make sense? Let me ask this question. You told me if I take absolute value of 2x plus 10 is equal to -15. You told me what about that? It's impossible. No solutions, right? Okay. Absolute value can never be negative. So what if I do this? When is the absolute value less than 0? Never, right? Because absolute value less than 0, we're saying that it has to be a negative number, right? Well, absolute value can never be a negative number, so there's no solution there. Even if I get like a -10 there, no solution there, right? Okay. What if I ask you this question? 2x plus 10, when is that greater than -10? Think about this graphically. 2x plus 10 is going to look, let me do a little bit of work in 2x plus 5, so it'll be 1, 2, 3, 4, 5. Be like that. Slopes are kind of jacked up there. And -10 is going to be down there. When is this v above -10? It's always above it, isn't it? So what x values would that be? Be all of them. Be all real numbers, right? -infinity to +infinity. Okay? So there are some times, now you go through the math and do all the math analytically, you'll get the same result. But there are times when looking at a question, doing a little bit of analyzing that question before I just start randomly writing stuff down. Okay? Do that foreshadow and think, what are we really asking here? Okay? When is an absolute value less than a negative number? Absolute value can never be less than a negative number. Okay? When am I asking absolute value to be greater than a negative number? Well, absolute value is always positive. Positive numbers are always greater than negative numbers. So that's always. Okay? So keep those things in mind. Those are going to help you as you move on. I think, Callie, you had a question yesterday. Was like absolute value of x is less than like 8 and less than 10, something like that, right? Now it's a between statement, and every between statement is really two statements wrapped up, right? Okay, inside it, it's a little bit different. If it was just this, okay, and maybe like x plus 2, we would solve that all together at once, right? But if it's absolute value, we want to treat it a little bit differently, and we want to treat it as individual between statements, okay, or yes, individual inequalities. So I'm going to rewrite this as absolute value of x is less than 10. And now I'm going to rewrite it as absolute value of x is greater than 8. Does that make sense? Okay. Now because it's a between statement, I'm going to rewrite it this way. I still need the betweenness or the and or the intersection idea. Does that make sense? Okay. And that and section takes precedent over any other operations that we come in a moment. So order of operations, that's kind of most important here in a moment. If you have absolute value like this, if it's a less than, don't you do this? Right? Now and, that takes precedence. You got greater than. Doesn't greater than become x is greater than 8 or x is less than negative 8? That makes sense to everybody? Okay. So what we're going to do is we're going to look at graphing that and graphing that. Okay. We're going to do it all together. But then we're going to look at this and that. And meaning intersection, meaning where they overlap. Okay. So if I graph that, I'll finish this on the smartboard. Have a great rest of the day. Make sure you look at that assignment so you can ask